Hi, welcome back to LeetCode. So in this video, I will discuss LeetCode problem 3645. Maximum total from optimal activation order. So you are given two integer arrays, value and limit, both of length n. Initially, all elements are inactive. You may activate them in any order. To activate an inactive element at index I, what is the condition? The number of currently active elements must be less than limit of I. So suppose I actually have x number of active elements. So that should be less than limit of I. That element actually I want to activate. So if it is satisfied, then next step will be what? When you activate the element at index I, it adds value I to the total activation value. So in our answer, it will be added, it will actually add the value of I. Clear? For all elements that have undergone activation operations. Okay, after each activation, if the number of currently active elements become x, so number of this actually x indicates the number of currently active elements. So then all elements j with limit j less than equal to x becomes permanently inactive even if they are already active. So I have to iterate all input array. Then it will check that can actually remove any um, elements permanently. So if actually I can remove, then actually I have to remove, and also I have to adjust the x. Okay, so now we have to return the maximum total actually I can achieve. So okay. So now go to the example, then actually it will be easy to understand that how it's working. Suppose we actually have limit 1 2 3 4 and corresponding value is v1 v2 v3 and v4. Okay, so initially our current number of active elements is 0 and our answer is also 0. So first of all I will choose suppose 1. Okay, so can I actually activate this element? Yes. First of all, first condition is what? I will check that how many currently active elements actually I have 0. That should be less than the limit is 1, so I can activate this. Okay, so I'll activate this, and after activation what will it will actually add the value of v1 into our answer. Got it? Now third step will be what? Before going to the next number, I have to check that can I actually remove any uh, elements permanently. So which number actually I can remove? I can remove only if the limit is less than equal to x. So here is the what is the x? X here is currently 1 because I have already activated this element. So x is equal to 1. So can I actually remove this element? Yes, because the limit is 1. So now it will be removed. Okay. Next, can I actually remove this element 2? No, because the limit is 2 and our current x is 1. So I can't remove. Next 3, can I actually remove this? No. 3 is greater than 1, so I can't remove this. 4, can I actually remove this? No, because 4 is greater than 1. Okay, so this is, so after deactivating this limit 1, so again it will be now 0 because they mentioned that if it is still active I can actually deactivate this, right? So now it will be in state, and now the current the count it will be 0 again. Got it? Next, go to the next number. So this is now not present, correct? Next, go to the next number 2. So 2, can I actually activate this? First condition is that the number of current activated I have that actually 0 and the limit is 2, so I can activate this. So I'll activate this, so it will increase by 1 and it will actually add the value into our answer v2. Got it? Next, before going to the next number, I will check that in the third step, can I actually remove any elements that actually limit is less than equal to x. So what is the x? X here actually is now 1, right? So can I actually remove this? No, limit is actually 2, so it is greater than x. Next is 3, can I remove this? No. 4, can I remove this? No. So still, so before going to the next number, what is the current state? The state is the current number of active elements is 1 and answer is this. Clear? So next go to the number 3. So can actually activate this. So how many x actually I have? 1, and limit is 3, current number limit is 3, so 1 is less than 3, strictly less than 3, so I can actually activate this. So I will activate this, and this count will be 2, and it will actually add into our answer v3. Got it? So in the third step, what actually check, can actually remove any elements. So any elements, so which number actually I can actually remove any elements that actually limit is, so x is now 2, so can I remove any elements whose limit is less than equal to 2? Yes, this number, the limit is 2, so now it will be removed. So after removing, so it will be also decreased by 1. Clear? Next is 3. Can I remove this? No, because our x is 2 and this limit is 3, so 3 is greater than 2, so I can't remove. 4, no, so I can't remove this. So before going to the next number, what is the state? State is the current number of active elements, it will be 1, and this is our answer. Next number I will go to the 4. Okay, 4. So x, it is currently 1 and limit here actually 4. So 1 less than 4, yes, I can activate. So it will be increased by 2. And it will also, second step, it will actually add the value also into our answer, v4. Clear? Now we go to the next number. I don't know, because in the picture you can see that there is no next number, but I have to adjust the state before going to the next number. So before going to the next number, I have to check that can actually, which number I can remove. So current x is now 2. Number of active elements actually it is 2. So these two numbers are already removed. So this 3. Can I remove this? No. 3 is greater than 2, so I can't remove this. 4 is greater than 2, I can't remove this. So our answer will be this. Finally, our answer is v1 plus v2 plus v3 plus v4. This is for all the numbers actually unique. Clear? Now suppose actually another example. Limit is 1, 1, 1. Value is suppose 10, 20, 30. Suppose we actually have 3 elements. All the limits actually same, 1, 1, 1, and corresponding value is different, 10, 20, 30. But our target is to maximize our answer, total value. So current active element, initially it will be 0 and our answer will be 0. Okay, so first try to take this element. Okay, so number of elements actually activated, that is active, that is 0, and our limit is also is 1, so I can activate this. So I will activate this, and this will actually number of active elements will be 1, and our current answer will be 0 plus 10. Clear? Now third step will be what? So current number of active elements is 1, so our x is equal to 1. So which number actually I have to remove? So I have to remove, can I remove this element? Yes, because 1 is less than equal to 1, means x. So I can remove this, I can remove this, I can remove this. So all 3 numbers will be removed. But our answer actually I got actually 10. Correct? Next, instead of activating this element, if I activate this element first, 30, whose value is 30, then our answer will be what? So initially active elements it was 0, and our answer is also 0. So I am activating this element, third element, so it will actually increase the our number of active elements 1, and our answer will be added by 30. Got? Similar way, after this first and second operation, in the third step I have to check that which number actually I can remove. So this number will be removed, this number will be removed, this number will be removed, but answer actually I got actually 30. Got it? So that means if actually I actually have any same limit, for same limit I have to choose the maximum value first. Try to take. Clear? For the same limit, try to take the maximum value first. Clear from this example? Okay. Now next situation is that Suppose we actually have 1 2 2 2. This is actually our limit, and suppose value. So I have already sorted in the order of the corresponding value, means the maximum value with the same limit, it will actually placed first. Suppose I actually have 10 30 20 10. Clear? Now from this example, current active element, it is initially 0. Our answer is initially 0. Now I can, in the first step, I can choose element whose limit is 2, and also I can choose element 1 also is possible, right? So which number I should actually choose? Suppose I have chosen this element 2. Okay, so can I actually activate this current element 2? Limit is 2 and the current number of active elements is 0. So 0 should be less than 2. Yes, so this is true. So I will activate this element, and this will actually add this value will be added into our answer. Next is, before going to the next number, I have to check that for the third step I have to check that which element I can remove. So current x is now 1. So can I actually remove this element? Yes, 1 is less than equal to x, so I can remove, so it will be removed. Next 2, so this was previously not activated, so it will be not adjusted. Next is this 2. Can I actually remove this? No, because 2 is greater than x. Similar for this. Now next, which number I can choose? This is already gone, this is already removed. Next, I can actually choose this. Yes. How? First condition is that number of active elements I have, that is 1, and limit is 2. 1 is less than 2, this is strictly less than 2, so I can choose. So I'll activate this element, and this value will be added into our answer 20. Clear? Now before, in the third step, I have to check that current active element actually I have, that actually 2, and I have to check that which number actually I can remove. So can I? This is already removed. This can I remove this? Yes. 2 is less than equal to 2, so I can remove. So this will be now removed. This will be now removed. This will be now removed. So what actually answer I got? That actually 50. Got it? In this actually I got actually 50. But suppose so, this is one way to get the answer. So now suppose I chose the first element as 1. So active element, it was 0, and our answer is, again I'm starting from scratch, so it will be actually elements will be 0, active elements is 0, and answer is 0. And I'm activating first element 1. So yes, I can remove, because 0 is less than 1, limit is 1, and current active element is 0. So I can actually activate this. So our number of active elements will be increased by 1, and this value will be added into our answer. Got it? Now before going to the next number, in the third step I have to check that which number actually permanently removed. So x is currently 1. So I have to check that which number actually limit is less than equal to 1 and still actually in currently present in the state. So I have to remove permanently, I have to remove that, correct? So that's why, let's see which actually I can remove. So limit is 1, 1 is less than equal to 1, so this will be permanently now removed. Clear? So this was previously active element, so it will be adjusted to 0. Clear? Next is 2. Can I remove 2? No, because active element x is 1, but our 2 is greater than 1. I can remove only if the limit is less than equal to x, then actually I can only remove. So that's why I can remove this. So similarly for this case also, this case also. Got it? So this is after first operation. So at the end, our active elements will be 0 and our answer will be now 10. Next, go to the next number 2. Limit is 2. So can I activate this? Yes. because 0 is less than 2, I can activate this. So our active limits will be increased by 1. And this in the second step, our value will be added into our, so please let us 30. So this will be added into our answer. Got it? Now third step, I have to check that which number actually elements actually I can permanently I can remove that. So x is now 1. X is now 1. And this is already removed. Can I remove this? No, because 2 is greater than 1. I can't remove this. Next, can I remove this? No. Can I remove this? No. So this will be our state now. Active elements will be 1. Answer is 40, and this 3 element is still active. Next, go to the next number, this. So this value will be 20. Can I actually activate this? Yes, because the current number of active elements is 1. 1 less than 2, I can activate this. So this will be increased to 2, and this value will be added into our answer. In the third step, what actually I have to check? So x value is now 2. 2 elements actually active. 30 and 20. These 2 elements actually are active now. So now before in the third step, I have to check that which number actually I can remove. So x is 2. Can I actually remove this element? Yes, because the limit is 2, which is actually less than equal to x. So this will be now removed. This number will be again removed. This number will be now removed. So here actually you can see that I have removed all the elements, and our answer, whatever actual answer I got, that actually 60, which is actually better than 50. Right? So that's why from this example, I hope this is clear. Thus, first of all, choose the elements limit is less. Correct? Whose limit is, choose the element whose limit is actually less first. Then if the limit is equal, then I have to choose whose value is maximum, because for if the same limit is L but value is 30 and 20, I should choose the first, this 30, because this actually maximize our answer. Got it? So this is clear that first of all I have to sort the our input array with according to the limit. If the limit is equal, then actually I have to sort it according to the values, maximum values at the front and the less value with the same limit at the end. Clear? So now go to the code. I hope this is clear, the logic, how it's working. So now how actually we will get the answer. So first of all, I have to know that currently how many active elements I have. Correct? So what actually I need? I have to track that. Track active elements, and 1 is the our answer. 3 is the, I have to check that which number actually I can remove. So to check that which number actually I can remove, what actually I need? What actually need this, that how actually we can remove which number? So that depends on what? It depends on the limit, current number of active elements and the limit. So first of all, I will create a pair with the limit and the value with the same index. Got it? Now I will sort this our input array with corresponding with according to what? First it will sort it according to the limit value. So the limit, whichever the limit value is less, that will be placed first. So that's why you can see that the first I will check that if it's not equal, then I will place that whatever actually the limit is less, that will be placed at the front. Clear? And if it is equal, then that means our limit is same, then I have to choose the maximum value, that will be placed at the front. So that's why it will come to this line number 15. If limit is equal, then I will actually, you can see that I will choose that if the value is maximum, that actually placed at the front. So I will choose a return true, greater than. If it is greater than, then it will return true. Clear? So after this operation, I actually have a sorted order according to the limit and the value. Now here actually I am using one priority queue. Why priority queue? Mean heap. You can see mean heap, because you can see that suppose effectively I have to remove in a third step after each operation in third step, I have to check that which number actually I can remove. So I am sure that like current limit is suppose 2. So suppose x is equal to 2. So which number actually chance is more to remove, more to be removed? That number which limit is actually less. So that's why I will choose a mean heap to store the limit, minimum limit at the top. So I'll check that the priority top, if it is less than equal to x, so I can actually remove from our current active elements. Got it? Why actually I am using the priority queue here, mean heap, basically to remove the, otherwise if suppose you take the max heap instead of mean heap, so what will happen? Our 2 will be present at the top, then actually 1 will be present at the leaf of the child of the node 2. So first of all, again I have to check that can I actually remove this? No. Again I actually go to this node, can I actually remove this? In this I have to check that. But if actually use mean heap, so easily I can say that yes, can I actually remove this? If I can remove this, then actually I will go to this. Otherwise, if I can't remove this, so I don't need to check this actually. Got it? Actually using the mean heap here to easily remove elements. Now this is clear. I am storing actually the limits. Now max limit actually indicates that till now, like it may actually happen that for this case, so 2 2 2 30 20 10. Okay, so in the priority queue I have already sorted according to this. You can see that after sorting I will get this value because all actually the same value, same limit, and I am actually storing according to the value, maximum value at the front, and according to that. Got it? Decreasing order. Now, so in the priority queue initially it will be empty. So first of all I will see that can actually what is the maximum limit? Maximum limit indicates that till this time, currently maximum limit means that how many actually the limit actually I have already removed or I have already deactivated. Or you can say that what is the limit actually I have already removed, permanently removed, right? So that means initially it is maximum limit, basically I am starting with 0 and our priority queue is empty. This is our priority queue. So can I actually store this? Yes, because maximum limit actually 0. So that means I have not removed any elements whose limit actually 2. So I can store this. So this will be actually stored into our priority queue and our answer will be added to 30. Clear? Next, still actually max limit is still 0. Can actually activate this element? Yes, because our priority queue size is still less than equal to 2, less than 2. So I can actually activate this. So again actually I am storing this 2 and this will be added into our answer. Got it? Next, when going to this element, I have to check that which number actually I can actually remove. So in the third step, before going to this number, I have to check that which number actually I can remove. So you can see that our current limit is actually 2. Current limit is 2, and how many actually active elements actually I have? That is also 2. So I actually have to remove all the elements that are actually less than equal to 2. So that's why I'll see that this number will be removed. Yes, this number will be removed. This number is removed. This number is present in the queue, so this will be now removed. Got it? Next, so this is now already removed from the queue. So now again our priority queue is empty. So now come to this element. Can I actually add this? No, because our max element actually I have removed, that actually 2. That will be adjusted to 2 because I have removed an element whose limit actually is 2. Correct? That means all the actual elements whose limit is 2, it may present here. Actually you can see that there is multiple elements present whose limit actually same 2. So that's why that will also be removed permanently. So that's why before inserting into the priority queue I have to check that this limit actually still actually valid or not. So current limit actually is 2, that actually should be less than, that should be greater than max limit I actually have removed till now. So this is false, so I can't add this into the priority queue. Got it? How actually I'm tracking this active elements and the all the actually elements we actually already removed permanently. So to check that which number already removed permanently, that actually tracking by max limit. This is already removed, and this priority queue actually storing all the active elements that can be actually permanently removed in some operation. Got it? So that's why. So in the priority queue, I'm storing all the limits, and this max limit actually indicates that till this time, what is the maximum limit actually I have removed or I have already deactivated this. And answer is the total value actually I can actually get. So now iterate the temp array actually I have already created according to sorted according to the limit value and the uh, limit and the value. Got it? So in each pair I will get one limit and the value. So first of all, I will store this into the priority queue. Okay. So I will see that, check that, can I actually add this into our answer. So when actually I can actually add this current element into our answer. So if the limit is the less than L, got it? I have to explain that third time actually I'm saying I will see this element, these two. So T2 is already removed or already permanently removed, but still actually I actually have in the array. So but I have to somehow know that till this time how much actually or what is the limit actually I have already removed. So that's why I will check that if the current maximum limit I have removed that is less than L, so that actually I can remove. Then actually I can add this. I can activate this current element. So it will be added into our answer. Next is I'll check that in the third step. This is the first step. I'll try to activate this, and when actually I can activate if our max limit is less than L, the current limit. But the third step is before going to the next number, I have to check that which number actually I can permanently remove. I can remove permanently. So I'll iterate the current x. Current x is actually size. Yes, this is a current active element. So I will check that whatever the number is present at the top of the priority queue, if it is less than equal to size or x, you can see this is actually the x. So that actually I can remove. So I will actually remove that from the priority queue and also adjust the max limit I am going to remove now. So that means suppose our max limit is now previously it was 0 and now I'm going to remove, suppose current size is 1. So in the top actually I have one element whose limit is 1, so it will be removed now. So in the next time actually if I see any element whose limit is again 1, so that will be now will not be added into our answer. So I'll actually to handle that I actually handle the max limit. Now I'm going to remove, so that will be maximum of the till maximum limit which I have with the priority queue top, whatever actually the top actually I have, and pop this from the priority queue to adjust the current active elements. Got it? And ultimately return the answer. So this, I hope this is clear. If any doubt, you will comment on that. And if you found this video useful, please like the video, and if not yet subscribe, please subscribe channel. Thank you. Bye.